The massive copper power lines stretching across our landscape, the ones that hum with energy and define our skylines, are about to become ancient history. Imagine a world where electricity travels silently and invisibly through the air, delivered by precision-steered microwave beams. It's not a fantasy. We are on the verge of turning our entire atmosphere into a seamless energy web, making physical grid failures and blackouts a thing of the past. Forget the tangled mess of wires. The future of power is wireless, and it's arriving sooner than you think. For over a century, we've relied on a 19th century solution to power our 21st century lives: copper wires. This aging infrastructure is buckling under the pressure of surging global energy demands. Every year, we lose a staggering amount of electricity, up to 10% in some regions, just from the resistance in these long-distance cables. That's like throwing away one of every 10 power plants worth of energy. Worse yet, these physical lines are incredibly vulnerable. A single ice storm, a hurricane, or a wildfire can sever power for millions, costing billions in repairs and economic disruption. And the high maintenance costs are a constant drain. And extending the grid to remote locations is a logistical and financial nightmare. We're trying to run a high-speed digital world on an old, decaying analog system. It's time for an upgrade. Think of it this way: we wouldn't use dial-up for our internet, so why are we using the equivalent for our electricity? The solution is to treat energy like data, broadcasting it wirelessly, talking about high-speed Wi-Fi, but for pure power. So, how does this invisible infrastructure actually work? It's all about precision. The system uses something called a phased array transmitter. This isn't a giant, crude antenna blasting energy everywhere. Instead, it's a sophisticated grid of thousands of tiny antennas working together. By minutely adjusting the timing or phase of the signal from each one, they can form and steer a highly focused beam of microwave energy with surgical precision across hundreds, even thousands of miles. This beam is incredibly narrow and targeted, ensuring almost all the energy reaches its destination. At the receiving end, we have a special device called a rectenna, which is short for rectifying antenna. It's essentially a mesh of tiny dipoles and diodes that efficiently captures the microwave energy and converts it back into the usable DC current that powers our homes, factories, and devices. It's a seamless point-to-point delivery system without a single physical wire in between. Naturally, the first question on everyone's mind is safety. Are we talking about giant death rays in the sky? Absolutely not. The intensity of these beams in the areas people might access is designed to be well within established international safety limits, often comparable to the levels you experience from cell phone signals. Furthermore, the system is built with multiple redundant safety protocols. The most critical is the keep-out zone sensor network. These advanced sensors constantly monitor the beam's path. If any object, a bird, a drone, an aircraft, is detected entering the beam, the system instantly pauses transmission in microseconds, long before the object even reaches the core of the beam. The power is only rerouted or resumed once the path is completely clear. It's a smart, self-regulating system that prioritizes safety above all else, making it far more secure than exposed high-voltage power lines that pose constant physical and electrical hazards today. One of the most revolutionary aspects of wireless power is its ability to bridge the last mile to remote frontiers. Think about disaster zones after an earthquake or a tsunami, where the first thing to go is the power grid, instead of waiting weeks or months to rebuild. We can fly in a mobile rectenna and instantly beam power from a transmitter hundreds of miles away, restoring communication, medical services, and clean water pumps within hours. The same goes for remote mountain communities or isolated research outposts that were previously off-grid. We can provide them with reliable, clean power without digging a single trench or erecting a single pole. This technology completely untethers industry from the grid. Imagine deploying a mobile factory or a mining operation anywhere on Earth, powering it wirelessly, and then moving it once the job is done. This flexibility will also supercharge our move towards automation, creating a network of autonomous drone charging stations that allow for continuous delivery services, or powering entire fleets of electric cargo ships as they cross the ocean. But where will all this energy come from? The ultimate power source for this global web lies in orbit. We're entering an era of industrial-scale orbital solar arrays. These massive platforms orbiting high above the clouds and the atmosphere will capture sunlight 24/7 without interruptions from night or bad weather. A solar panel in space can generate vastly more energy over its lifetime than an identical one on the ground. These orbital power plants will collect immense amounts of clean solar energy, convert it into microwaves, and then beam it down with pinpoint accuracy to large antenna farms located just outside major city hubs. This provides a constant, reliable baseload power source that perfectly complements intermittent ground-based renewables like wind and traditional solar. While ground solar sleeps at night, space solar will be powering our cities. It's the key to a truly stable and 100% clean energy future. The final piece of this puzzle is the creation of a truly borderless energy economy. When power can be traded as easily as data, the geopolitical landscape of energy changes forever. Countries rich in renewable resources, whether it's constant sun in the Sahara or powerful winds in the North Sea, can become global energy exporters, selling electricity instantly across continents without the need for expensive, politically complex international cables. This creates a global energy market where electricity flows to where it's needed most, stabilizing prices and enhancing global security. Urban design will also transform. Buildings will no longer be passive consumers of electricity. With rectennas integrated into their facades or roofs, they will become active nodes in a decentralized energy mesh, able to receive power directly, store it, and even share it with their neighbors. This vision leads us to a future where energy access is no longer a privilege tied to geography or wealth, but a universal right. A world where a child in a remote village has the same access to clean, reliable power as someone in a sprawling metropolis. The wireless power web is not just an infrastructure upgrade. It's a fundamental shift in how we power human civilization. Thank you so much for watching. If you're as excited about this incredible future as I am, make sure to like this video, subscribe to the channel, and hit that notification bell so you don't miss our next deep dive into the technologies shaping our world. See you in the next one.